Hello guys, welcome to Startpad Tutorials. In this session, we'll be discussing about the industrial truss. As you can see in the figure, this is gonna be the truss, and when extended, this will be the 3D view. So let us start the session. Initially, start Staad Pro. Select new project. Select truss. Give it a name. Units will be meter and kilonewton. Select next. Finish. As soon as you have drawn, you got the grid. So you can see this is 7 meters, whereas the half of it is 3.5 meters. So you can see there is a beam too here, and there will be a angular section here. So first we will be doing is we will be converting this to 20 by 20, then this zero point 0.5 by 0.5 spacing, and you will select 0 to 3.5 and 3.5 to 7, whereas coming to width is 12 meters. So you can see we need more along width-wise, x-wise. So we'll give 24. So 12 meters, and once again 3.5 and the end. Now select escape, and you can switch off the grid. So now that you have drawn the base part, and coming to truss part, we go to geometry, select run structural wizard. Select have a roof. As per our figure, it is have a roof. Double click it. Length is 12 meters. Number of base is 8. Height is 3 meters. Coming to width, what we'll do is we'll select 0, select apply. Well, this is the truss. Now you need to transfer this truss exactly so that it can meet this point, which is y equals to 7 meters. Select OK. OK. So you can see this has been done. Now select the entire structure, go to geometry, select translational repeat. Select translational repeat, and global direction will be Z direction. Number of steps will be 12, and default spacing, well, let us take 1.5, yeah, 2 meters. Just take 2 meters. Select OK. Or else, as you can see, what we'll do is we'll just delete the entire thing. We go to geometry and structural wizard, select have a roof, select 12, E8, and height will be 3 meters. Coming to width, we'll select width as total 20 meters. Number of bays will be or 30 meters. Number of bays will be 10. Select apply. So I can say in this way. Now I can transfer this model exactly at 7 meters from origin. We can see this is the model. If you switch on the grid, you get like this. Then you can draw up to 3.5, then 7, and then to the end, or else we'll just draw from here once again. Select escape. Now you can switch off the grid, select those two, go to geometry, select translational repeat, select number of steps as 10, default spacing as 3 meters in Z direction, select here link steps. Now select OK. Now you can see all of them gets linked as shown in the figure. Viewing the front view, it will be like this, similar to the structure shown here. So now we'll be taking this under columns, then the outsiders one will be double angles and the insiders will be angles. So we go to general, select define, go to assign profile, select angle, select double angle, and select channel. Channel will be assigned to the columns and double angle will be assigned to the outsiders members. Then angle will be assigned to inside members. Then let us select for angle section database. In section database we'll select particular angle as per our Indian. Select angle, select 40 by 40 by 6, select add, or else you can define it later. We can go with supports, create fixed supports, then going for loads, well, trusses basically resist wind loads, so we add wind definition. You can select here intensity will be 1.5 and height is 7 plus 3 10 meters. You calculate as far as ASCE. Here select trussed tower. This is more of a industrial truss, so this would suffice. Select apply, OK, then add. Select factor 1, add, close. Assign the factor to the nodes. Now you can go to load case details. First load will be dead load, the next one will be live load, and then will be window load, and next positive, window load, and next negative, window load, and Z positive, and window load, and Z negative. Go to dead load. First what will select is self weight, then coming to member load we'll select minus 12 kilonewtons per meter. Then we'll select roof load, which will be minus 2 kilonewton per meter square. Exactly at the roof, which will be 7.5 meters minimum to maximum of 11 meters. Actually it is 10 meters we need, however we can keep 11. Going to live load, so we add member load minus 6 kilonewton per meter. Wind load, we select wind load, so we can see the wind load being assigned. Once we are done with the wind load, you assign the loads. You can see there is a you can see the load can be applied. Now going to self weight, assign it to the entire structure, then coming to uniformly distributed load, which will be along the beams in 3D view, along these beams and this one. So what we'll do is we'll go to front view. Using node we'll select it. Well, the nodes get selected. So in this way you select all those horizontal beams as well as these beams. Well, these don't exist. Now you can see, and assign to those beams. Similarly, this load also assign to those beams. Well, now that you have assigned all those loads, you go to load combinations, select define combinations. First one will be 1.5 dead load plus live load plus wind load x positive. Select here 1.5. Next one will be 1.2. Z positive. So we select 1.2. So 2 will be enough, as you know how to add combinations. Then we go to design tab, select particularly IS code 800, then select parameters FI, LD. You can give 500 or 415. Then you give commands check code and take off. Assign it to the whole structure. Well, once you are done with assigning, you can go for analysis. So there is a error. Let us see what error it might be. Yeah, I can say that elastic modulus not entered for member 320. It means that we have not assigned property to few members. There goes those, there goes those. Okay, see, we have assigned angle to those middle members as well as double angle to those end members and channels to those, but we forgot these members along the endwise. So we go to view and select those members and assign channel to them. Fine, then after assigning you can analyze. Well, there are still errors. Let us see what they might be. So there are errors yet saying elastic modulus not entered. So go to select by list, select beams, then you can search 321 in this to find that particular beam. Oh, so you can see we still forgot all those members nodes. Well, what we'll do is we'll select all those nodes so we'll assign angle to all those remained members. In this way we can assign angle property. See, these members also been remained. Using beam cursor you need to select in order to select the members. Now assign to those beams. Now run the analysis once again and see if there is any error. Still there might be or might not be. So there are no errors. You can go to modeling by specification all failed beams. So there are these many failed beams since we have, according to the code, they assigned only these angles. So you can just delete those and assign channel, select section base, go to Indian and select channel and select whatever you like. ESMC 250 assign, yes, close. Then go to double angle section database, go to Indian, select double angle, in the sense angle, give here long leg back to back double angle, select which one you, whatever you like. As I said in the before class, this is a trial and error method. You need to check more and more to be economical design. Even if you select and there are failed members, you can go to design tab and select the command select, so it selects the members optimistically. Now we check for any failed beams. So there are still failed beams. What we'll do is we'll just go to design, define commands, select and take off. Now these commands will assign to the entire structure. Yes. Now we analyze the structure. Now you can go and see specifications or failed beams. There are still these failed beams. So what we'll do is we'll go to general property. Instead of channel, we'll remove the channel. We'll define a beam column and assign the column to those selected beams. Then once again we need to run the analysis. If we use select command in design tab and there still exists any failed beams, then we must change the member. If suppose angle fails, then we can select double angle or we can select a channel. We need to improvise with time in these situations. So you can see there are no failed beams. Go to post processing, select OK. So select 3D view. Well, you can see the deflection occurring in this way, particularly for live load. Let us see for that's very big for the load combination. Then for another load combination, you can see coming to reactions are obtained at each and every node point. Stresses, graphs can be obtained, animation can be seen. Where you can change the live load. The scale is big, that is the reason it is very much shaking. Reports can also be obtained. So in this way an industrial truss is designed, and this is the end of the session. Thank you. Do subscribe to this channel for more videos.